Hey guys, my name is Nogan. Welcome to my Java series. So in today's video, we are continuing with arrays. But now in today's video, we'll be focusing on a multi-dimensional array, or for example, a two-dimensional array. So in today's video, we're going to be focusing on trying to understand how do we implement from a two-dimensional to a three-dimensional or to a four-dimensional, but only in this case right now, we'll be looking at two-dimensional arrays in Java. So if you haven't watched the previous video, we focus on two dimensions. I'll link a card on top to check it out, because the context of the video of course will be important for this one as an extension of arrays. So let me jump to the IDE, NetBeans, go to file in your project, go next, and let's rename this let me think. Okay, let's say geological data. Yeah, awesome. So let's just rename this Java file into a much more standard main class. Okay, let's just rename this to geological data analysis, which means just on the end lines, of course, this being the main class. Okay, awesome. So after this now, when you try to build a program that does some analysis based on using arrays or now three dimension as a form of now storing data, of course, in memory, and how we can use that, of course, execute a few functionalities of those data. Okay, so before you continue here, let's also include another Java file. Let's go to click on, just right click here and go to new Java class. Let's rename this to, let's just name this geological data. Let me see. Okay. Yeah. Awesome. Now in here, let's write first a few functionalities, two functions, and also a few things about how this a public class can use, of course, now data as a means of now analysis, because right now we want to focus in this video how to make sure that we can try to define data in a multidimensional concept of arrays, and how we can use it, of course, now for analysis. It's very interesting. So basically now here I'm going to say public. It's a few functions: public static void. I'll just say populate function name, populate geological data. Okay, so the function, of course, will take now, of course, here a double variable, but now it takes, of course, 3 indexes. Let's give this a variable named double data, and also in here let's declare, of course, a few functionalities. Okay, so right now we're going to use, of course, now sample data as a means of now analysis. Okay, so in this class name of geological data here, and in this function, of course, by definition, I'll declare, of course, another variable double. Now this variable, of course, will be used for storing, of course, the data that is essential for analysis. So again, I'll include 3 indexes. Now after something, just say this is sample data. Alright. Now after this, you have to, of course, try to initialize our data. So let me just include here semicolon. Now in here, I'm going to include again 3 curly brackets, because we want to use this, of course, means of storing data. And now, awesome. Okay, so in the first, which means we have 2 indexes here. We have 3 indexes. So this is the first index here, the second, and the third. So each of these indexes, of course, contains information in a fundamental multidimensional. But of course, in this use cases here, each index is linked to the other index, of course, for information. Because why? Each of these, of course, has its own functionality, but how many data have been used, of course, to be stored here. So each of these will contain, of course, a 3x3 matrix, a 3x3 array of data to be stored, of course, in here. So I'll just say it here, curly brackets again, So let's just include sample data. So I'm going to say 10.5, then 20.3, 30.1, right? In here I'm going to say 40.0, 50.2, and 60.3. What am I doing? Let's come here. Awesome. Now in here in the last color bracket 70.5, then 80.4, 90.7. Awesome. Okay. So now in the second index here, I'm going to also include a few color brackets for fluorine data. I'm including here 15.5, 25.3, and 35.1. I'm going to include here now 45.0, 55.2, 55.3, and also in the last color bracket here 77.5, sorry, and also 85.4 and 97.95.7. Yeah. Okay. Again here. Okay. I'm gonna say 12.5, 32.3, 32.1, 32.0, 32.2, 62.3. The last one we have 82.5, 82.4, and 92.7. Awesome. Okay. Now let's just discuss about what was happening here. So basically, we want to, of course, analyze geological data. What does it mean by definition? It means, of course, now if we try to, for example, try to like create a 3D model, for example, 3D model of a geological surface. We want, of course, information about, of course, like the depth of the surface, the depth. We want, of course, also now the latitude, and also we want also now the longitude. Yeah, just forgive me for my bad handwriting. Latitude. Okay, so these three, of course, now will become our fundamental storage information for data. Because why? Each of these contains, of course, now a 3x3 matrix. 3x3 means we can store, of course, now here a 3x3 matrix of data to be of course used for analysis. But now, because we want to build a 3D model of the geological data that we have, which means we want to create a surface area of like how it looks based on this given sample data, of course, here. So this the idea of having, of course, these, because this will be focusing, of course, being the depth. This, of course, will be now the latitude, and this will be, of course, focusing on the longitude of the geological surface 3D modeling. Awesome. So based on what we have here as a fundamental thing. So after this, of course, let's include another function. Now, the other function, of course, does something specific, which means we want to focus on the necessity of trying to simplify few things. Because think about it. In here, okay, we have to also include a for loop, because remember, each of these, of course, contains information. So each for loop, of course, you have to iterate and use as like a iteration search algorithm to search through each of these as a means of finding, of course, like the data being stored there for each of those indexes of 3D by x. Let's say, for example, the x-axis, the y-axis, and the z-axis based on this three arrays here. So based on that, I'm going to say now here for loop int d is lies to 0. Now d is less than sorry data dot length, right? Then I'm going to say, of course, d plus just for implement. I'm going to say for loop again here, int again. I'm going to say lat for latitude, initialize. Okay. I'm going to say again here lat greater than less than data dot length. And now before we say length, because think about it, because we are moving in a for loop now, we need to, of course, also to keep track of the outer for loop. Before you can say that, you have to focus on now. You say, okay, data, of course, will be in the form of taking the change of variation, of course, of these for outer for, because now here you have to also include a index that contains, of course, the information of the outer for loop. You say length again. Then you will say, of course, now latitude plus again. Awesome. So the reason why we're doing this, because think about it. Data, of course, is a variable here containing, of course, now indexes, like for example, this is the x-axis here, the y-axis, and the z-axis. So if you're going into the inner for loop, this for loop here takes, of course, into consideration the condition of elements contained, of course, in the d variable here, based on the data, the length of it, which means you want to also focus on like the length of this data length of d compared to the latitude, of course, here, of like how many times does this condition also needs to be evaluated based on the condition of this outer for loop here. It's like a comparison, which means the outer for loop must first execute to allow an access now for the inner for loop also here to be executed. After it, now another for loop, int long for longitude, and also initialize to 0, and when I say long is less than data. But now, because think about it, because we have now, of course, two outer for loops, there will be now two indexes here. The first one will be called for d, the second one for latitude, and dot length again, fundamentally speaking. Then long again, focus on this. We're going to use the increment operator to increment that, of course, a few times. Okay, awesome. So after it, now I'm going to say, based on what we have, essentially, we're saying, of course, in this, we'll be saying we want to focus on the data, the index, latitude index, and longitude index. This should be, of course, be compared by based on the sample data of d, of latitude, and also of longitude. But what we're doing eventually here is, of course, we're just copying, of course, now this information in this for loop, in this nested for loop here, as a means of trying to make sure at least we can use the data in this for loop to try to iterate a few times when you try to render each of these, because remember, these are coordinates here. These are coordinates here, and these coordinates, of course, contains information. For example, this is the x-axis here, by definition, of course, think about it. This is the y-axis, and this is the z-axis. So fundamentally speaking, when you have something like this, of course, a Cartesian plane, where you, of course, you have your x-axis here, your y-axis, and your z-axis here. When you, of course, drawing a surface area of something here, let's say, for example, the surface area of this data here, which means this surface area, of course, will have like each variation. For example, this can be, of course, like in a different color or different spectrum. This could be like in a form of a dot, which means each of these coordinates, of course, here justifies how we draw, of course, this 3D geological model of the Earth's surface here as a means of observation. Awesome. So based on that, now let's continue by also focusing on adding another public function. So after this, of course, here, because now we have now this public static void function here. After this, I'm going to do another public static, it will be double variable, double function. Now we're going to focus on calculate, of course, now the average. The average because when I focus on the average of the data being used, of course, now in that population of the geological data based on this function here. So this one is calculated, of course, now based on what we have here based on the sample data. So now here I'm going to say double again as a parameter, 3 indexes again, data. Perfect. Now here, of course, I'm going to just say double sum. Now sum, of course, initializes 0. Then we have int count, which means I'm going to count, of course, a few times. Then I'm going to say for loop again, which means what I don't know, like the function of this, like the reason why we have this function of calculate average is want to calculate the average, of course, of the data being used in that observation, which means want to see that like the sum divided by the count. What do we have the average of the geological data we have as an approximation? So let's say for loop here. I'm going to say int d again. Basically, let me just copy because now let me just copy this because we're going to use the same next for loop here. Just copy this and paste it here again. Awesome. Now, what is going to happen right now here? I'll use the, of course, here now sum plus is equals to the data, then indexes of d, latitude, and longitude. Let's count again, plus. Awesome. Now, before we wrap up here, because of course, think about it. We have two functions here. One function is a void function, means it doesn't return any type, any output, anything to justify, because the return function return a value to justify the function was being called in the main function and has been executed. The void function doesn't return any type. Now the double functions or the value returning functions like this one needs to return a function, needs to return a value. And of course now in Java, of course, because I'm saying functions, these are called now methods, which means this method, of course, of public set a double here needs to return, of course, now here a type. So now here it will return now the sum divided by the count. Awesome. So we have two methods, of course, here of public static void and also now of public static double here. So which means we have two methods to be used, of course, now in the main class for observation. Now if you come back here, now let me remove this, of course, here. Let's focus now on the essentials. How do we test, of course, now what we have there as data? So now I'm here, I'm going to just say, now I'm going to focus on, let me just include a comment by saying, now the dimensions of the geological data grid, which means we focus on the depth, the latitude, and of course the longitude. Awesome. So I'll say int depth. So now this variable, of course, here initialize to, okay, I'll just do this, 3, int again, latitude, again, int, then longitude. Awesome. So okay, after this, I'm gonna say now, because these three, of course, are what we'll be using, of course, to test the data being declared, of course, now in this class of geological data here. Now, if you're coming back here, let's just, of course, try to initialize the data. I'm gonna say, of course, now here double again. Now double, I would say geological data equals to new double. Now I'm going to say here depth, latitude, then longitude. Let me see what is happening here. Oh, made a mistake. Okay, so basically also here I need to include those indexes. Essential, because everything needs to be smooth and on point. Awesome. Okay, so after this, I'm gonna just try to use now the population function, because now let me just do a comment here, which means we have a population, we populate the array with sample geological data, which means we're gonna just call it function, but I'm gonna use, of course, now by definition, of course, now that class, which means I'm going to just say here geological data dot populate, which means going to use that. Awesome. Then I'm going to just say again here double. Now average value as to geological data dot calculate function. Awesome. Okay, let's say system out and line average geological data value. Let's say average again value. Awesome. Okay, basically what's happening here, we're going to use of course now this function to try to populate now use the population for the populate geological data function to of course now get the average value of that geological data based on analysis, because we want to focus on analyzing of course the data now before now the 3D modeling based on this. Okay, so after that now let me just clean up all this. Awesome. Let me run this and see output. Awesome. So basically you can see now here based on the output here, our average geological data value of course is now 52.6, sorry. So which means this is of course now almost like our estimated value. So we can use this now as a reference about now how accurate can we try to model of course now the 3D surface based on this. So guys, I hope you enjoyed the video. I know it's a little bit long, but now I just want to show you guys of course now how to have like build like a class that contains of course database in 3D, or let me say like a multi variable array of data. They can do some analysis of course. You can store data of course, you can use data of course now for analysis. So thank you for watching. Don't forget to like, subscribe if you're new, and see you next time.